Good evening to all. Today I'm here to discuss about feedback amplifiers. In previous videos, I posted about the BJT amplifiers and FIT amplifiers. So first introduction to feedback amplifiers. So the main function of the feedback is mainly for reducing the distortion present in the output of the amplifier circuit. The feedback amplifier circuit has been implemented in the analog circuits. So first the feedback is mainly used in virtually in all amplifier system. It is invented in 1928 by Harold Black, engineer in Western Electric Company. So this is the one of the main methods to stabilize and improve the gain level of the amplifier circuit. Mainly it is utilized in the telephone repeaters. So in feedback system, the output signal is always proportional to the input of the amplifier circuit. So this is the general feedback amplifier. So in amplifier, we are applying one input signal and corresponding output is generated in the circuit. So first, A denotes the amplifier circuit and beta is nothing but feedback factor. So beta is nothing but feedback factor. So here already the output is amplified. So the amplifier output is the part of the sampled output is taken and it is again feedback to the feedback part. So this is our feedback block. So again we are feeding to the input of the amplifier circuit. So the main purpose of the feedback amplifier is to reduce the distortion and then to improve the stability factor and stability level of the amplifier circuit. So based on the input and output signal of the amplifier circuit, it is classified into two types of feedback amplifier. First one is positive feedback amplifier and then negative feedback amplifier. So so we can see the definitions of the feedback amplifier is the process of injecting a fraction of output signal of some devices and feedback to the input of the amplifier. So based on the input and output of the circuit, it is classified as two types. So next slide discussing about this positive feedback amplifier. So the positive feedback signal, the circuit consists of amplifier and then beta, and we are applying input. So we are applying 360-degree signal as an input of the amplifier. Here in positive feedback, a portion of output signal is feedback to the input in same phase of the signal amplifier circuit. So by representing the positive feedback amplifier, that is it increases the overall gain of the amplifier. So here the positive sign represents the same phase. So that means the amplifier circuit after feeding the input to the feedback block, the circuit it maintains the same phase value in the amplifier circuit, that is nothing but 360-degree. So here the feedback signal is in same phase or in phase. So mainly for improving the or mainly for increasing the gain of the amplifier circuit, the positive feedback has been introduced. Here the positive feedback increases the gain. So the main applications of the positive feedback is mainly we are utilized in oscillator circuit and signal regeneration and then comparator circuit. Here the positive feedback amplifier is also called as the regenerative amplifier based on the input and output signal. And next one, negative feedback amplifier. In negative feedback amplifier, a portion of the amplitude of the output signal is sent back to the input of the amplifier. So that means the feedback signal is in the opposite phase, that is in out of phase. That is 180-degree out of phase of the original input signal. That is called as negative feedback amplifier. That's why here mentioning this is amplifier and this is beta is nothing but feedback factor, and we are applying full sinusoidal signal as an input. The corresponding output is generated, that is based on the amplification of the signal with the feedback factor. So at the end we are getting only the 180-degree out of phase of the negative feedback circuit. So this is the main function of the negative feedback amplifier, and we can also Mainly in feedback amplifier, from these two types, we are using only negative feedback amplifier. So mainly the negative feedback amplifier, it reduces the distortion and noise, and it can able to improve the stability factor of the amplifier circuit. So this is the main function of the negative feedback amplifier. And then few applications of the negative amplifier is we can utilize in the applications such as the regulated power supply, and then audio systems and electronic information processing, mainly for improving the performance of the stability level of the circuit and reducing the gain and reducing the distortion and the noise. And same way, with negative feedback amplifier, we can increase in the bandwidth based on the frequency ranges of the amplifier circuit, and we can control the input and output impedance level of the negative feedback amplifier. So in real-time applications, for practical applications, we are from these two types of amplifier. We are using only the negative feedback amplifier due to the advantages of the uh, stabilization factor. And then next, this is the comparison of the positive and negative feedback amplifier. So the future, so input we are applying sinusoidal signal. So the in feedback amplifier, based on the input signal, it adds the feedback signal mainly, and it causing the increasing level of the signal. And in negative feedback amplifier, it subtracts the feedback signal from the input, and it causes the decreasing of the signal in the negative feedback amplifier. And in positive feedback amplifier, either 0 degree or 360 degree phase shift will be introduced at the end of the output of the positive feedback amplifier. In negative feedback amplifier, the output signal is based on the input signal. The output signal is present in the out of phase or in opposite phase, that is 180-degree phase shift will be introduced in the negative feedback amplifier. And distortion, so when compared to the negative feedback amplifier, in positive feedback amplifier, due to the 360-degree phase shift, here it introduces some few distortion in the amplifier circuit. Here, due to the phase shift of the output level of the phase shift, here in negative feedback amplifier, the distortion is less when compared to positive feedback. And stability level, here in positive feedback amplifier, due to the oscillations present in the saturation region, the stability level decreases. In negative feedback amplifier, the circuit, it increases the stability level and it makes the system as more stable when compared to the positive feedback amplifier. And based on the frequency ranges, the bandwidth are noted for both positive feedback amplifier and the negative feedback amplifier. So here, based on the frequency ranges, here in positive feedback amplifier, we are getting only the low bandwidth, and in negative feedback amplifier, we are using the kilohertz frequency ranges. So up to few kilohertz frequency. So based on that, the bandwidth level of the negative feedback value, negative feedback amplifier will get increases. So this is the comparison of the positive feedback amplifier and then negative feedback amplifier. And then next, so this is the general structure of the single loop feedback amplifier. So this is the entire network of the feedback amplifier circuit. So first block is nothing but signal source, and second one comparator or mixer network, and then third one basic amplifier, that is in forward transfer gain. In general, in amplifier circuit, gain is denoted as gain. So that's why here representing the forward transfer gain as A. And the next block is nothing but sampling network block, and out at the end of the block we are connecting the load resistance, that is RL, it is denoted as RL. And finally we are taking output at the end of the amplifier circuit. So the output of the amplifier is, again we are feeding feedback to the input of the amplifier circuit, that is we are giving input at the comparator part and as well as at the mixer network. So this network is nothing but the feedback network reverse transmission. So here beta is denoted as feedback network. So this is the entire block diagram of the feedback network. So first we are applying input as a signal, that is sinusoidal wave as an input. And next one, in comparator circuit. So the network consists of both the sampling network and then signal source, and also the feedback network. So it consists of mainly the resistive configuration in the comparator or mixer network. And then next we are applying signal as either current or voltage based on the signal what we are applying as an input. It may be either a current or voltage. And next, an amplifier which increases the magnitude or amplitude level of the input signal based on V voltage and the current. And next, sampling network. The sampling network, when it comes to the sampling network part, it consists of two sample at the end of the output. One is voltage or node sampling, and then current or loop sampling. So based on the voltage and a node, and based on the current or loop, here the sampling process will be takes place in the feedback amplifier circuit. So either it may be in series connection or in shunt connection. Based on that, uh, we can plot the sampling network, and also we can fix the series and shunt connection based on the voltage and current network. Next one, a load resistor. Load resistor is connected at the end of the feedback amplifier circuit. And next one, the comparator mainly consists of the two mixer network. One is based on the series input connection and based on the shunt input connection. So based on the series and as well as the parallel connection of the voltage and current relations, we are fixing the comparator or mixer network in the amplifier circuit. And next one, feedback network. So this will mainly, the main purpose of the feedback network is to improve the gain and stability level of the amplifier circuit. We are introducing the feedback network in the amplifier circuit. So it is denoted as beta. So from the feedback network, we are applying voltage to the input of the amplifier circuit. It is denoted as feedback voltage, and I is denoted as feedback current. This is the entire structure of the amplifier circuit, feedback amplifier circuit. And next, advantages of the negative feedback. Mostly we are using the negative feedback amplifier. The main advantage is it improves the gain, and also gain level, due to the variations of the gain, noise will be get reduced. And the bandwidth level of the feedback amplifier in negative feedback is we are getting high bandwidth based on the frequency ranges. And SNR ratio also get increases, that is signal to noise ratio can also get improved due to the negative feedback. And next one, reduction of nonlinear distortion. In this negative feedback, the noise will be low, and we can control the input impedance and output impedance of the feedback amplifier circuit, negative feedback amplifier circuit. And based on the mixer network, based on the comparator, here the four, four topologies has been classified based on the voltage and current. So there are four types of, we know that already there are four types of amplifier circuit. One is voltage amplifier, current amplifier, transconductance, and then trans resistance amplifier. So here, how we classify the series shunt and shunt series feedback, and then shunt feedback. It is full and full based on the voltage and current, and based on the mixing and then sampling network. So in previous block diagram, I discussed about the sampling network and then comparator network. So here, based on the voltage and current input, we are fixing the input as in series connection and output of the network in the shunt connection. So based on the input mixing and output sampling, here the shunt series and series connection has been defined. So this is the main four feedback topologies of the feedback amplifier circuit. Here, the series shunt feedback is amplifier is called as voltage amplifier, and another name of the current amplifier is nothing but shunt series feedback amplifier, and transconductance amplifier is nothing but series feedback amplifier, and then trans resistance is nothing but shunt feedback amplifier. So in feedback amplifier topologies, for all the four types of classifications, we are going to solve the input impedance, output impedance, and then gain of the amplifier, feedback amplifier network. And next, this is the full feedback configuration. So first one, In previous slide, I mentioned the 4 configuration. So here, first one is nothing but series shunt. So first at input side, we are using, this is the mixing circuit, and output side we are using sampling network, and this is the load resistance is common for all the configuration. So here at input side, the circuit connection takes place, that is the voltage source and feedback connection takes place in the series connection. And when it comes to the output side, the output is connected in parallel connection. So this is the uh, circuit configuration of series shunt. And when it comes to the shunt series connection, shunt series configuration, at input side we are connecting the feedback network in parallel, that is nothing but shunt connection, and output side we are connecting in the series connection. And in series connection configuration, we are connecting the feedback network in both input and output connection only in series. So that's why here represented as series connection. And next, shunt connection. So here both input and output side we are connecting the feedback network in parallel connection, that is called as shunt connection. So based on the input mixing and the output mixing of the network, the feedback configurations are classified as 4 types. So this is the general basic for feedback topologies. This is taken from the connection. It fully based on the series and parallel connection of the input network and as well as the sampling network. And for every configuration, we are solving the gain value, input resistance, and output resistance of the configuration. So first, this is the hybrid model circuit diagram for series shunt configuration. So this is the main general equation of gain of the feedback amplifier. So here, AV is nothing but voltage gain feedback amplifier is equal to AV by 1 plus beta V into AV. So the gain value of the feedback amplifier is common for all the types of feedback network. And next is series shunt connection. The input resistance RAF is nothing but RA into 1 plus beta into AV. And by using similar in same way, by using the hybrid model circuit, we are calculating the input resistance and then gain value, and gain value is common. And then for series configuration, RAF is equal to RA into 1 plus beta Z into AG, and R naught F is equal to R naught into 1 plus beta into AG. So by applying the KVL to the input loop and as well as the output loop, we are taking the RIF and R naught value for each and every configuration. And next, this is the general comparison of the feedback amplifiers based on the parameters like gain with feedback and then stability factor and then frequency response, frequency distortion, input resistance and output resistance for each configuration. Here the input resistance and output resistance has been calculated. Here the gain is common for all the feedback amplifier. So based on the parameter, the terminal can be different. So for example, here in voltage series, it is nothing but voltage amplifier. So the term we are mentioning as AV, and for current shunt, we are mentioning GM. So GM is nothing but it comes under the transconductance amplifier. So that's why we are mentioning GM. And current shunt is nothing but current amplifier circuit. So we are representing the current as AI. And for voltage shunt amplifier, it is nothing but trans resistance amplifier. So the trans resistance amplifier is denoted as RM. So here the gain value will be based on the values. Here the value will get increases and then decreases. So for here in all the type of amplifier, the gain value will get decreases. So and next one, stability level. So for all the configuration, stability level get improved. So this is the main purpose of the feedback amplifier. So from the analysis of the gain, RIF and R naught F, the stability value will get improved, and frequency response also improved and distortion will be low. And then by the analysis of the circuit, by using the hybrid model circuit, we solved the calculated the RIF and R naught value for each and every configuration. Next one, thank you.